Welcome to the mathematics of my channel. In this video we are going to evaluate this golden sum. So why I called this is a golden sum. Okay, let's see the answer. Okay, first I'm going to define an integral. So if we take integral from 0 to 1 t to the n 1 minus t to the n minus 1 t. Now I think this is a little bit familiar with us because this is a type of beta function. We know the definition of beta function. Beta of xy is equal to integral from 0 to 1 t to the x minus 1 times 1 minus t to the y minus 1 dt. Okay, now here we have t to the n, but here x minus 1, so we can change the power like t to the n plus 1 minus 1. Then here we have 1 minus t to the n minus 1 dt. Now we know this is equal to beta of n plus 1 comma n. Now we know the relation between gamma function and beta function. Beta of xy is equal to gamma of x, gamma of y over gamma of x plus y. So we can write here gamma of n plus 1 times gamma of n over gamma of 2n plus 1. Okay, gamma of n plus 1 we know n factorial, here n minus 1 factorial over 2n factorial. Okay, now I'm going to multiply both numerator and denominator by n. So here we have n factorial. N times n minus 1 factorial we know, again n factorial over n times 2n factorial. Okay, then we know here we have 1 over n times 1 over n times. Now n factorial times n factorial over 2n factorial, we know this is equal to 1 over 2n choose n. 2n choose n. Okay, now we can take our sum, our summation. N is equal 1 to infinity minus 1 to the n plus 1 over n times 2n choose n is equal to, now we can write this is equal to infinite sum. N is equal 1 to infinity, integral from 0 to 1, then here minus 1 to the n plus 1 minus 1 to the n plus 1 times t to the n 1 minus t to the 1 minus t to the n minus 1 dt. Okay, if we take this sum of n is equal 1 to infinity minus 1 to the n plus 1 times t to the n times 1 minus t to the n minus 1. So if we apply 1 here, we know we have t. Then if we apply 2, so here we have t square 1 minus t, then t to the third power 1 minus t square, 1 minus t square, then minus so on. Okay, now we know this is a geometric series, so we can write this is also equal to t over 1 plus t times 1 minus t. So now we can take our sum is equal to s. So we can write now s is equal to now here integral from 0 to 1, integral from 0 to 1. Now this sum we know is equal to t over t over 1 plus t times 1 minus t dt. Okay, then here if you multiply minus t square, so I'm going to take minus sign as a factor. So minus integral from 0 to 1. Now here we have minus t square, so t square, then plus t, so minus t, then plus 1, so minus 1. And here in the numerator we have t, but if we differentiate the denominator, we have 2 times t minus 1. Therefore I am going to take 1 half 2 times t minus 1. Now we know these 2 get cancelled and we will have t minus 1 half, so we should add plus 1 half dt. Okay, now we can split this integral into 2 different integrals, so we can write minus 1 half is a constant, so 1 half integral from 0 to 1 2 times t minus 1 over t square minus t minus 1 dt, then again minus 1 half integral from 0 to 1 dt over t square minus t minus 1. Okay, then we know here minus 1 half derivative of the denominator is equal to 2 times t minus 1, so we have in the numerator, so natural log of t square minus t minus 1 from 0 to 1. Then here we have minus 1 half integral from 0 to 1 dt over, here we can write this is as a perfect square t minus 1 half square, so t square minus t. Now here minus 1, so also we should subtract 1 over 4, so here minus 5 over 4, minus 5 over 4. Now if we apply limit, we know this part will be 0. S is equal to minus 1 half, here minus 1 half, but we can take minus sign as a factor, so plus 1 half integral from 0 to 1. Then here we have 5 over 4 we can write the square root of 5 over 2 square, then minus t minus 1 half square here dt. Okay, then we know if we have integral from dx over a square minus x square, this is equal to 1 over 2 times a natural log of a plus x over a minus x plus c Okay, therefore we can integrate this, so we can write here 1 half 1 over 2 times a 1 over 2 times, now a we know square root of 5 over 2, so square root of 5 over 2 natural log of, now a plus x, a we know square root of 5 over 2, so square root of 5 over 2 plus x we know t minus 1 half over, here we have the square root of 5 over 2 minus t minus plus, so plus 1 half. Here a limit we know 0 to 1, so here limit 0 to 1. Okay, then we know these 2 get cancelled, so we have 2 times square root of pi. Now here we have natural log of the square root of pi minus 1 over 2, square root of pi minus 1 over 2, we know the reciprocal of golden ratio 1 over phi plus here t over, here we have the square root of pi plus 1 over 2, we know golden ratio, so p minus t from 0 to 1. Okay, then we can apply limit here 1 over 2 times the square root of pi natural log of now if we apply 1, we know here 1 over phi plus 1, So 1 plus p, 1 plus p over p. Here we have p minus 1. Okay, then if we apply 0 here, minus natural log of 1 over phi over phi, so 1 over phi square. Okay, then we can simplify. We know this property of golden ratio, phi square is equal to phi plus 1. Now here we have phi square minus phi, so we can write now here 1 over 2 times square root of pi natural log of, now here 1 plus p. Now phi square minus phi, we know 1, so we have only 1 plus p. And then here we can write 1 over phi square, we can write phi to the minus 2, so minus minus plus plus natural log of phi square. Okay, then we can write again 2 times square root of pi natural log of 1 plus golden ratio plus then here we know phi square is equal to phi plus 1, so we have natural log of p plus 1. Now according to property of natural log, we can take multiplication, so here 1 over 2 times square root of pi, here natural log of 1 plus p perfect square. Okay, now we can write this is equal to this 2, we can take here, so this 2 and this 2 get cancelled, so we have 1 over square root of pi natural log of 1 plus golden ratio. Okay, this is the answer for this summation. Thank you for watching.